the heading Formation of PDE, which is the first heading in the unit Partial Differential Equations. So usually question will be solve the equation, right? Whatever unit you take, question will be solve the equation. But here you see form the equation is the question, right? So when we solve equation, we get solution, right? So we need to form the equation. So solution will be given. With the help of the solution, we form the equation. Okay. So why this heading is, so in order to know, there are two types of solutions. We have two types of solutions available. One is solution with arbitrary constant. So there is solution with arbitrary constants. And another one is solution with arbitrary functions. Arbitrary functions, okay. So there are two types of solutions available. One is solution with arbitrary constants, other one is solution with arbitrary functions. So if this solution is given, let us see how can we form PDE, okay. If this solution, that is solution with arbitrary constant, is given, how can we form PDE, okay. So let us take such solution z equal to ax plus by plus ab, okay. So it is solution with a and b are arbitrary constants. You know z is function of x comma y throughout the unit, right? Z is function of x comma y. A and b are arbitrary constants. You know constants, right? Constant. Arbitrary. They can take any value. A and B can take any value. Okay, they can take any value. A and B are arbitrary constants. That is, A and B can take any value. So this is solution with arbitrary constants. Okay. So first step what we do is, let us check how many number of arbitrary constants and how many number of independent variables. So there are two arbitrary constants and two independent variables. You know independent, dependent, right? In the last video we discussed. So numbers are same. Number of arbitrary constants is equal to number of independent variables. Numbers are same, right? Then we get, when we form equation, the equation will be answer. Answer is equation, right? Equation will be PDE of order 1. Okay. Equation will be PDE of order 1. First order differential equation. So we get answer first order differential equation. And you know the notations, right? P, Q, R, S, T, right? P is dou Z by dou X. Q is dou Z by dou Y. And R, S, T second derivatives, right? So we get PDE of first order. That is PDE which contains P and Q only. Okay. So let us see this problem. So the solution is given ax plus by plus ab. Okay. We are going to find equation now, partial differential equation. So the method which is very simple, mark it as first equation. Differentiate z partially with respect to x. When you differentiate partially with respect to x, this y is constant, right? Take a outside, differentiate x with respect to x 1. B, y both are constants. When you differentiate it will become 0. A and B both are constants. When you differentiate it will become 0. Okay. Differentiate z with respect to y partially. When you differentiate with respect to y, x is constant. Already A and B are arbitrary constants. X is constant now. When you differentiate a and x with respect to y, it will become 0. When you differentiate by with respect to y, it is b. When you differentiate ab with respect to y, it is 0. So we know notation, it is actually p, it is q, right? So this is our second equation, this is our third equation. Substitute second and third equation in first equation. Z is equal to px plus qy plus pq, which is the required partial differential equation. Okay. So what it is, in the lesson here, I told you we are seeing the heading formation of PDE. So usually question will be solve the equation. So we find the solution. Equation will be given, we find the solution. But here it is different, form the equation. So what it will be, solution will be given, we form equation. When equation is given, we find solution. When solution is given, we find equation. So we can form equation. So there are two types of solutions available. So in order to know there are two types of solutions available, this heading is given. This heading is given to know that there are two types of solution available. One is solution with arbitrary constants, other one is solution with arbitrary functions. Let us see now the solution with arbitrary constants. So, and this is the question, right? You can see A and B are arbitrary constants. This is solution with arbitrary constant. So before doing any problem, first you check whether number of independent variables and number of arbitrary constants are same. If they are same, our answer will be equation of first order, partial differential equation of first order. So let us take, the method is very simple here. When the numbers are same, when the number of independent variables and the number of arbitrary constants are same, it is very easy, okay? Method is very easy. Mark it as first equation, the given solution. Differentiate it with respect to x partially, y partially. Then we have to eliminate A and B using these three. You can use these three equations, eliminate A and B. Get solution free from A and B, okay? So we have, the solution is actually question, form equation. So with the help of these three equations, we are going to form PDE. So you eliminate arbitrary constants, you will get PDE. This is partial differential equation because P and Q are derivatives. You know an equation which has derivatives called partial differential equation. P and Q are first order derivatives. So it is partial differential equation of order 1. Okay. So PDE of order 1. So this is the way how we do. Let us see another example. Z equal to x square plus a square into y square plus b square. The problem. You can see A and B are arbitrary constants. X and y are independent variables. Z is the dependent variable which depends on x and y. So number of independent variables x and y is equal to number of arbitrary constants a comma b. The numbers are equal. So this is actually solution. We are going to form the equation. So heading is formation of equation, right? So this is solution. So when the numbers are equal, you know, we will get equation of first order, PDE of first order, right? So it is enough if we find first derivatives. So let us differentiate first. This is first equation. You know method. Differentiate z with respect to x partially. When you differentiate with respect to x, y is constant. Since they are in multiplication, the entire term is constant, take outside. Y square plus b square. Differentiate x square, we get 2x. So it is p is equal to 2x into y square plus b square. Okay. Next you differentiate the same z with respect to y partially. So this x square plus a square is constant, right? They are in multiplication. Take the term outside. If they are in addition, you know how to differentiate. They are in multiplication. Take the term outside. Differentiate y square plus b square, which is 2y. When you differentiate b square, it will become 0, right? When you differentiate y square, it is 2y. First you reduce power. Differentiate y, which will give 1. So it is 2y. So q is equal to 2y into x square plus a square. Our first equation, second equation, third equation. So it's very clear we will get answer in terms of P and Q, first order partial differentiation, right? Partial differential equation, right? So what we did in the first problem, we got A answer, B answer and we substituted, right? We substituted. So we have got answer, right? Very simple problem. But every time we cannot expect like this, right? Here also it is simple. If you want, you can find first B answer from this, A answer from this, substitute A and B here, then simplify. So which we make ourselves the problem complicated, okay? So it's very simple. When you simplify, you will see little bit complication, right? So what is our need? we have to get PDE which is free from A and B, right? So instead of finding A and B answer substituting, find y square plus b square answer, replace it. X square plus a square answer, replace it, which will give you the final answer, right? So what is y square plus b square? P by 2x. X square plus a square, q by 2y. So this is our second equation. This is our third equation. Using 1, 2 and 3 here, listen here, using 2 and 3 here, you will get z is equal to q by 2y into p by 2x. I have substituted for these two, right? So which is z is equal to pq by 4xy, or 4xy z equal to pq, which is the required partial differential equation. So this equation is free from a and b, right? So we have eliminated the arbitrary constant and we have got equation. So this is solution given. We have found equation. So this is partial differential equation because it contains p and q. An equation which contains partial derivatives called a partial differential equation. So it contains p and q, hence it is first order partial differential equation, which is the answer needed. Okay. Let us see another problem. Z equal to ax power n plus by power n. A and b are arbitrary constants. X and y are independent variables. So before doing, you should know whether your equation will be first order PDE or second order PDE. When the number of arbitrary constants is equal to number of independent variables, the equation is first order partial differential equation. Our answer contains only P and Q. Okay, no R, S, T. Okay, so two arbitrary constants, two independent variables. So method is simple, right? Mark it as first equation. Have two columns. Differentiate z with respect to x. Take a outside. Differentiate n x power n into x power n minus 1. After reducing power, differentiate x, which will become 1. And this term will become 0 because both b and y are constants, right? Similarly, differentiate z with respect to y partially. This a into x power n is constant when we differentiate with respect to y. Hence, it will become 0. Another term we have b into y power n. Take b outside. Differentiate y power n. Then differentiate y, which is 1. So, p is equal to n into a into x power n minus 1. Q is equal to n into b into y power n minus 1. Right? P and Q. And it's very simple. You can find answer A and substitute. Answer B and substitute. Okay? Otherwise, if you think, listen here, if you think smart, you will get easily another form of, another method. See, x power n into x power minus 1. Similarly, b y power n, y power minus 1. Where x power minus 1 is 1 by x, we know, right? X power minus 1. Similarly, y power minus 1 is 1 by y. Cross multiply. Xp equal to n into a x power n. Yq is equal to n into b y power n. You can get by power n answer. By power n, which is yq by n. Ax power n, which is xp by n. Ax power n is equal to xp by n. By power n is equal to yq by n. This is our second equation. This is our third equation. Listen here, this is not the only method. Even you can find A answer here, B answer here and substitute. Okay? Substitute in the first equation. No problem. You have to simplify. If you do this, simplification is easy. Because you can get a x power n. What is a x power n instead of a? Our aim is to eliminate a and b, right? You can find a answer and replace, or if possible a x power n answer and replace. Okay. So I substitute second and third equation in my first equation. Z equal to xp by n plus yq by n. Okay. Taking n LCM, nz equal to xp plus yq, which is the required partial differential equation. So when solution with arbitrary constants given, you know how to form PDE, right? You know how to form PDE when solution with arbitrary constants given. That too, number of arbitrary constants and number of independent variables is same, right? Let us see another problem. Let us see now another problem where two arbitrary constants and two independent variables. A and B are two arbitrary constants. X and Y are two independent variables, okay? X and Y are two independent variables. Z is function of X and Y. Z is a dependent variable. We count independent variables and arbitrary constants. So X and Y are independent variables. A and B are arbitrary constants where the numbers are equal. Hence our answer is equation of order 1. PDE of order 1. Partial differential equation of order 1. That is, our answer contains only P and Q, first order derivatives. So when the numbers are equal, our answer contains only first order derivatives, P and Q. Okay. So let us take for this as first equation. Differentiate first equation with respect to x partially. Reduce power 2 into x minus a. Then differentiate x minus a, which is 1. Differentiation of x is 1, a is 0. Then when you differentiate y minus b whole square with respect to x, it will become 0, which is equal to cots. A and b are arbitrary constants. Alpha is fixed constant, okay? Fixed constant. A and b are we count arbitrary constants. Alpha is fixed constant. So you can take cot square alpha outside. Differentiate z square, which is 2z. After reducing power, differentiate z. Dou z by dou x. Okay. 2 into x minus a equal to cot square alpha into 2z. Dou z by dou x. Both sides 2 get cancelled. X minus a equal to z into p into cot square alpha. I told you, right? Find the answer a and replace, simplify. Or if you are smart, you can replace x minus a. Because we want answer free from a and b. A and b. So instead of finding a replacing, you can replace x minus a itself. Anyhow, we will get answer free from a and b. Right? So this is our second equation. Then differentiate this y minus b, the same first equation with respect to y. When you differentiate with respect to y, this will become 0, being constant. This will become 2 into y minus b. Then after reducing power, differentiate y minus b with respect to y, which is 1, which is equal to cot square alpha is constant, take outside. Differentiate z square 2z. After reducing power, differentiate z. Dou z by dou y. So both sides 2 get cancelled. Y minus b equal to z into q into cot square alpha, which is our third equation. So it is enough to find p and q here, right? Because no need of finding r, s, t, second derivatives. Because we have already confirmed before doing problem, right? Let us substitute 2 and 3 in first equation. Zp cot square alpha the whole square. Zq cot square alpha the whole square equal to z square cot square alpha. You can write z square p square cot power 4 alpha, z square q square cot power 4 alpha, z square cot square alpha. You can take z square cot power 4 alpha common. P square plus q square equal to z square cot square alpha. So p square plus q square equal to z square cot square alpha by z square cot power 4 alpha. Where z square get cancelled, cot square alpha get cancelled. Denominator cot square alpha. We know 1 by cot alpha is tan alpha, right? Tan square alpha. So our answer is p square plus q square equal to tan square alpha, which is the required partial differential equation. Okay. So you know now when solution is given, how to find the equation, right? how to form equation. For two, so listen here, for two arbitrary constants, two independent variables, you know method. Let us see now the problem with three arbitrary constants, okay. Question is, find the PDE of all planes passing through the origin. So we know equation of plane, general equation of plane. Do you know general equation of plane? General equation of plane is ax plus by plus cz plus d equal to 0, which you studied in school, right? Ax plus by plus cz plus d equal to 0. Okay. It is given, it's all planes, right? Why all planes? When a, b, c, d take different values, we get different planes. That's why it said all planes. All planes passing through origin. So this plane passes through origin, right? When this first equation passes through origin, what will happen? 1 passes through origin, 0, 0, 0. When it passes through origin, x is 0, y is 0, z is 0, which will give d is equal to 0. So when this equation of plane passes through origin, then d will become 0. Okay. Substitute this d equal to 0 in first equation. We will get the plane passing through origin. This is general equation of plane. When it passes through origin, d is 0. Substitute. So what is the equation of plane? Equation of plane passing through origin is ax plus by plus cz equal to 0, which is the required equation, right? This is equation for the given problem, right? Second equation. You look at this now and see the difference of other problems and this problem. What is the difference? We have a, b, c, three arbitrary constants. X and y, two independent variables. You know z is dependent variable. Z depends on x and y. Z is function of x and y throughout the unit. So z is dependent variable. X and y are independent variables. Number of independent variable is 2. But the number of arbitrary constant is 3. Number of arbitrary constants are 3. The numbers are not equal. They are not equal, right? So in such case, you should know, we will get equation which is of order 2. Second order partial differential equation. Our answer will be second order partial differential equation. When the numbers are not equal, our answer will be second order or higher order partial differential equation. Okay. So let us try. The same step. First step is same. See, first have two columns. Differentiate second equation with respect to x. Differentiate second equation partially with respect to x. The word partially is very important, right? Differentiate partially second equation with respect to y. When you differentiate with respect to x, a is constant, x with respect to x is 1, by is constant which will become 0 when you differentiate with respect to x. Cz, take c outside, z is not constant, okay? Z is function of x and y. So it can be differentiated with respect to x and also with respect to y, okay? Equal to 0. A plus cp equal to 0, which is one equation. Similarly here, differentiate second equation with respect to y. This term becomes 0. We will have b. Differentiate, take c outside, differentiate z. Z is not constant, keep in mind. B plus CQ equal to 0. So it's very clear our answer will contain second derivatives also. So we have to differentiate further. This is our third equation. This is our fourth equation. Differentiate third equation with respect to x again. Differentiate partially third equation with respect to x. Differentiate partially fourth equation with respect to y. Okay. When you differentiate with respect to x, a will become 0. Take c outside. What is differentiation of dou z by dou x? Dou square z by dou x square, which is 0. Similarly here, differentiate b, which will become 0. Differentiate this term, take c outside. Differentiate dou z by dou y with respect to y. Dou by dou y of dou z by dou y. Dou square z by dou y square, which is 0. When you get c this side, it will become dou square z by dou x square equal to 0. Dou square z by dou y square equal to 0. This is r, the notation. This is t, the notation. Okay. T is equal to 0. And listen here, let us get s also. You know how will we get s, right? Differentiate this equation with respect to y, or differentiate this equation with respect to x. You will get s. S equal to what is s? Dou square z by dou x dou y, right? So let us take this equation. Differentiate third equation with respect to y. Okay. Differentiate third equation partially with respect to y. Partially is very, very important. Okay. When you differentiate partially third equation, a will become 0, c take outside, differentiate it with respect to y. So you should not think yourself that it is function of x, okay? It is function of xy because z is function of xy. So it is function of xy. Differentiate it with respect to y, dou by dou y of dou z by dou x, which is dou square z by dou y dou x, okay? Dou square z by dou y dou x. We have outside c equal to 0. So which is c into s equal to 0 or s equal to 0. We need answer free from ABC, right? Already we have got answers. We can stop, right? Being first problem, I'm showing you how will you get, if there are more solutions, how will you get more solutions. It is enough if you get one solution. R is equal to 0 is free from ABC. T is equal to 0 is free from ABC. This is second derivative R, right? Any equation with partial derivative is called a partial differential equation. So it is a PDE, the required PDE. You can stop. But I want to show all the solutions exist for this problem. This is another PDE. This is another PDE, okay? Another PDE. So let us see whether we can get any other PDE from the equations. Any other PDE. You can see here you can see a plus cp equal to 0. Okay. Here I have ax plus by plus cz equal to 0. I can get a answer, b answer. If I substitute that a answer, b answer, everywhere I have c. I can take c outside where I will get answer free from ABC, right? This is another solution. It is enough if you find one answer, okay? I am showing you all the 4. There are 4 answers exist for this problem. I am showing you all the 4 answers, okay? So from this equation, I get A is equal to minus Cp. What we have? A is equal to minus Cp. B is equal to minus Cq. From third equation and from fourth equation. Third and fourth equation I have got. So depending on your way of thinking, you will get different solution. So which proves I tell you, right? So let us substitute this A and B in this equation. Minus Cp, minus Cpx, A is Ax, minus Cpx, By, minus Cqy, Cz equal to 0. Take minus C common or take C common. It is Px plus Qy minus Ez equal to 0. When you bring minus C this side, it will become Px plus Qy plus minus Qy minus Z equal to 0. Or Z equal to Px plus Qy. Which is another answer, right? Which is another PDE. What are the answers available? R equal to 0, T equal to 0, S equal to 0, Z equal to Px plus Qy. So for the given solution, this is solution, right? and we have formed equation, 4 equations. So all these 4 equations have same solution, ax plus by plus cz equal to 0. Okay. So this problem has 4 equations. It is enough to get only one answer. Okay, one answer. So you can think, you think, and you do. If you think r equal to 0 is enough, you stop. Okay. So this problem has 4 equations for this solution. Okay. So this is solution of these 4 equations. So we have formed PDE for the given solution. Okay. Let us see another problem. Find the PDE of all spheres whose center lie on z-axis. So we know equation of sphere, right? Equation of sphere whose center is ABC and radius r is x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. So this is general equation of sphere with center a, b, c and radius r. Listen here, it is given center lie on z axis. You know, see, x axis, y axis, z axis. If the center of sphere lie on z axis, then the point on z axis will be x will be 0, y will be 0, z will be some point. Let us choose C. Okay. So center of sphere lies on z axis. And hence this equation becomes x square, because a is 0, y square, b is 0, z minus c whole square equal to r square. This is the equation of sphere whose center lie on z axis and radius r. This is our first equation. So what are the arbitrary constants here? C and r. R is radius. Radius can differ. It is not said in the problem. Radius is same for all spheres. What is the meaning all sphere? When a, b, c and r takes different values, we get different spheres. That's why it is all spheres. It is not said in the problem. Radius is same for all spheres. So radius is also an arbitrary constant. It is not a fixed constant. It is an arbitrary constant. So r is arbitrary constant. C is arbitrary constant. So C, center of sphere differs, right? When C takes values, it is different. So C and R are arbitrary constants. It's very clear. There are 2 arbitrary constants and 2 independent variables x and y, right? 2 independent variables. And numbers are equal. 2 independent variables, 2 arbitrary constants. Z is dependent variable, okay? We count number of independent variables and number of arbitrary constants. C and R are arbitrary constants. You know meaning arbitrary. They can take any value. The constant can take any value. Okay. So C and R are arbitrary constants. When the numbers are equal, our answer will be partial differential equation of order 1. First order partial differential equation. So solution is given. We are going to find the equation. Okay. Equation. So form the equation is the heading, right? Let us do the same method is simple, right? Simple. It's not 3 arbitrary constants to find second derivatives. It is enough to find first derivative, right? So differentiate first equation with respect to x. 2x, y square becomes 0. 2 into z minus c. Differentiate z, dou z by dou x equal to 0. So now I differentiate the same equation with respect to y. Okay. So what is the equation? See. Here it is x square plus y square plus z minus c the whole square equal to r square, right? When you differentiate x square with respect to y, it is 0. When you differentiate y square with respect to y, 2y. When you differentiate z minus c whole square with respect to y, 2 into z minus c, differentiate z. So you know first you reduce power, then you differentiate the term z minus c, which is equal to 0 being our constant. So I have both sides. Listen here. I can write I can write 2 into z minus c into p is equal to minus 2x. Similarly, 2 into z minus c into q equal to minus 2y. Both sides 2 get cancelled. Z minus c into p equal to minus x. Z minus c into q is equal to minus y. Now this is my second equation and this is my third equation. Since we have only two arbitrary constants here, see, c and r, only two arbitrary constants, right? So we will get only first order PDE, right? So listen here, usually we, what we do is we try to eliminate arbitrary constants between 1, 2 and 3. We eliminate between 1, 2 and 3. But here you see, if I replace for z minus c either this or this in the equation here, if I use, I will still get r. R is also arbitrary, right? So we should not have r in the final answer. If I use z minus c answer, here I will get r. So what I say is I cannot use either this or this there. What I do is, it's not compulsory that you have to use all the three equations to find answer. Okay. So what I do is, if I see, I can easily say I need answer free from A and B. I need answer which is first order differential equation, right? So it is not must that I have to use all the three equations. So I can easily say from these two I will get answer, right? If I get z minus c here, which is minus x by p, z minus c minus y by q, equating the two, minus x by p equal to minus y by q, or x by p equal to y by q, or xq equal to yp, or yp minus xq equal to 0, which is the required partial differential equation. So what is the question actually? Find the PDE of all spheres whose center lie on z-axis, right? So we know what is equation of sphere. Since its center lie on z-axis, definitely the point on z-axis will be 0, 0, some c. Hence this equation becomes this form, where c and r are arbitrary constants, which is our first equation. Then since two arbitrary constants, two independent variables, we will get first order PDE as answer. So let us differentiate that with respect to x, y, and after simplification, listen here, from these two I can easily say I can get answer, right? I can get answer which is free from arbitrary constant. I have not used first equation, right? I have not used the equation where I have two arbitrary constants, right? So because this cannot help us to eliminate both arbitrary constants, but from these two I can get answer, right? So which complete problem. Let us see one more problem. Find the PDE of all planes having equal intercepts on x and y axis. Okay. We know equation of plane, general equation of plane, which is ax plus by plus cz plus d equal to 0. But we want now equation of plane in intercept form. What is equation of plane in intercept form? Equation of plane in intercept form is x by a plus y by b plus z by c equal to 1. This is equation of plane in intercept form. Okay. What is intercept? A is x-intercept, B is y-intercept, C is z-intercept. Let us see. X-axis, y-axis, z-axis. A is x-intercept, right? B is y-intercept. C is z-intercept. See? What is intercept? The point which touches the axis, the point, this A touches the axis, right? We call it as intercept. A is x-intercept, B is y-intercept, C is z-intercept. So x by a plus y by b plus z by c equal to 1 is the general form, equation of plane in intercept form. The given problem, you read given problem, equal intercepts on x and y axis. X-intercept is A, y-intercept is B, and the intercepts are equal given. So A is equal to B. The intercepts on x and y are equal. A and B are equal. So this equation becomes x by A plus y by A plus z by C equal to 1. Okay. So the equation becomes x by A plus y by A plus z by C equal to 1, which is first equation. Now it's very clear, two arbitrary constants A and C, two independent variables x and y, the numbers are equal. Hence our answer will be PDE of first order. We are going to form equation, right? Our answer will be PDE of first order. Okay. So let us listen here. And in a method, we have done many problems, right? And first we differentiate first equation with respect to x. Take 1 by a outside, differentiate x, which becomes 1. Differentiation of y by a becomes 0. Take 1 by c outside, differentiate z with respect to x. Differentiating 1, 0. Okay. Similarly, differentiate with respect to y partially. Take 1 by a outside. This becomes 0 when you differentiate with respect to y. Take 1 by a outside, differentiate y, which is 1. Take 1 by c outside, differentiate z, which becomes dou z by dou y. Z is not constant, right? Z is dependent variable. So we have to differentiate. So from this I can say 1 by a, this is p, right? P by c equal to 0. 1 by a plus q by c equal to 0. So I have got a second and third equation. How can I eliminate the arbitrary constants? How can I eliminate? Listen here. So I told you it is not must to you always use all the three equations, right? If possible, you can use these two and get answer. I can say, right, 1 by a equal to minus p by c. 1 by a equal to minus q by c. From these two I can see minus p by c equal to minus q by c. Minus get cancelled and c will also get cancelled. P is equal to q or p minus q equal to 0 is the required partial differential equation. This is equation which has partial derivatives. Partial differential equation. Even question is form PDE, right? Form the equation. So the given one is solution and this is the question. This is the question. We are framing question for the given solution. Okay. So which complete this problem. We shall see one more. Okay. Next question. Find the PDE of the family of spheres having the centers on the line x equal to y equal to z. Let us write family of spheres. See, the equation of family of spheres is x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. This is equation of, general equation of sphere whose center is a comma b comma c and radius is r. Okay. So it is given this is family of spheres because when a, b, c and r takes different values, we will get different sphere, right? That's why they say family of spheres. It is given center lie on x equal to y equal to z, right? What it is given? Center of the sphere lie on the line x equal to y equal to z, okay? Center is a, b, c, which lie on this line x equal to y, which is equal to z. That is what is the meaning? A equal to b equal to c. Okay. So the equation of sphere, general equation of sphere becomes x minus a whole square, y minus a whole square, z minus a whole square equal to r square. So we have two arbitrary constants a and r. It is not said r is fixed constant, right? R is fixed. It is not said the radius is same for all, right? So r is also arbitrary. R also can take any value. It is not fixed. So there are two arbitrary constants a and r, two independent variables x and y. The numbers are same, right? The numbers are same. Hence, we are going to find PDE, right? The PDE will be PDE of first order, P and Q, which contains only P and Q. Two independent variables, two arbitrary constants. So the PDE will contain P and Q only, which is first order PDE. Okay. So which is first equation? Since the same method for like two arbitrary constants, how we do? The same method. Differentiate first equation partially with respect to x. Differentiate first equation partially with respect to y. When you differentiate with respect to x, it is 2 into x minus a. This y minus a whole square becomes 0 when we differentiate with respect to x. Z minus a whole square become 2 into z minus a. First you reduce power, then differentiate z minus a, which is dou z by dou x equal to 0 or is constant. Similarly here, this term will become 0 when we differentiate with respect to y. This become 2 into y minus a plus 2 into z minus a dou z by dou y. First you reduce power, then you differentiate the term. Okay. I can write it as 2 into z minus a into p equal to minus 2 into x minus a. Both sides 2 get cancelled. Z minus a into p equal to minus of x minus a. Similarly here 2 into z minus a into q equal to minus 2 into y minus a. Both sides 2 get cancelled. Z minus a into q equal to minus of y minus a. Okay. So I have got second equation and third equation. Let's see first equation, right? Second equation I have got answer, third equation. So I have to eliminate a and r. So if I substitute for x minus a or z minus a, y minus a or z minus a, I cannot eliminate this r. Okay. So this equation cannot help. I need answer free from arbitrary constants because I am forming PDE by eliminating arbitrary constants. Okay. So a and r. R cannot be eliminated with the help of both of these equations. You substitute and see, you will have r. So what we do is, we have to get answer from these two equations. We have to get equation PDE from these two equations. So how can we get, if you think, see, I have z minus a. If I bring p this side, similarly if I bring q this side, I can equate the answer, but still we will have a. Still we will have a. I need answer free from a and r, right? So what we do is, let us simplify. Zp minus ap equal to minus x plus a. Get all terms, a terms one side, other terms other side. Taking a common, p plus 1. So a is equal to zp plus x divided by p plus 1. Similarly here also we find a. Zq minus aq equal to minus y plus a. Get all other terms one side and a terms other side. Take a common. Hence a is equal to zq plus y by q plus 1. So I have got a answer here, a answer here. Equate the two, you will get answer free from arbitrary constants a and r. Zq plus y. Right? 1 second, I show you. See? Equating both a's, you will get this answer. This is the answer which is free from arbitrary constant. Listen here, you can leave the problem here. And if you want, you can simplify it more. Simplify it more, it is your choice. I simplify this, see, cross multiply. Cross multiply, which is p plus 1 into Now multiply first term into first term. First term into second term. Second term into first term. Second term into second term. Similarly here, first term into first term. First term into second term. Second term into first term. Second term into second term. Let us get all terms one side. ZPQ plus QX plus ZP plus X minus ZPQ minus PY minus ZQ, right? ZPQ get cancelled. Let us listen here. I have P term here and here. So take P common. Z minus Y into P. I have Q term here and here. Take Q common. X minus Z into Q. Let us get other terms other side. Y this side, X this side. Which is the required PDE. So this equation is in the form PP plus QQ equal to R. You can leave the problem here. We need answer free from A and B. You can leave the answer here. And if you want, listen here, if you simplify more, you will get this form answer, right? PP plus QQ equal to R. But this equation is called Lagrange's linear equation. And we will discuss about this equation later, okay? You just know the name, Lagrange's linear equation. You know very well what we are doing now. We are forming PDE. This is PDE because it contains partial derivatives. We have eliminated arbitrary constants and we have got PDE, right? Solution was given and question is found, right? This is question actually, right? We have formed equation. Solution was given. From the solution we have formed PDE. So this solution, this equation is in the form. This is equation PDE which is in the form PP plus QQ equal to R. Capital P is Z minus Y. Capital Q is X minus Z. Capital R is Y minus X. So this equation is called Lagrange's linear equation. We will see about this equation later, okay? We shall see one more problem. Obtain the PDE by eliminating A, B, C from x square by A square plus Y square by B square plus Z square by C square equal to 1. Okay. So here, there are three arbitrary constants and two independent variables x and y. What is given? X square by A square plus Y square by B square plus Z square by C square equal to 1. Two independent variables, three arbitrary constants. So the numbers are not equal, right? Numbers are not equal. So the answer will be PDE of second order, right? PDE of order 2. Answer will be PDE of second order. Okay. That is our answer will contain RST. Okay. So this is the equation given. Let us mark it as first equation. You have to differentiate first with respect to x, then with respect to y, again with respect to x, again with respect to y, then s. You should find s, right? So p, q, r, s, t. And when you do, you can understand at one stage you will find answer, okay? Or if you do some simple adjustment, you will find answer, okay? Let us do. Differentiate this equation with respect to first equation. Differentiate first equation partially with respect to x. So when you see it is, take 1 by a square outside, differentiate x square 2x, then y square by b square, when you differentiate with respect to x, it is 0. Take 1 by c square outside, differentiate z square, which is 2z. First you reduce power, then you differentiate the term z. Don't forget to differentiate the term z, okay? After reducing z square power, then you differentiate z. So which is this one? Let us write it as 2z by c square dou z by dou x equal to minus 2x by a square. Both sides 2 get cancelled. It is z by c square into dou z by dou x equal to minus x by a square. Okay. This is a second equation. Let us find third equation. Differentiate first equation with respect to y. So this term becomes 0, right? This becomes 2y by b square, right? 2y by, when you differentiate with respect to y. This becomes 2z, take 1 by c square outside, 2z. Then you differentiate z with respect to y. So what it will be? Take 1 by b square outside. Differentiate y square with respect to y, which is 2y. Similarly, 2z by c square into dou z by dou y equal to 0. Okay. Similarly, you do simplification. 2z by c square into dou z by dou y equal to minus 2y by b square. Or both sides 2 get cancelled. Z cube by c square equal to minus y by b square, which is third equation. So we have to differentiate this again with respect to x, because it is the problem with 3 arbitrary constants, right? So differentiate second equation again with respect to x. Take 1 by c square outside. Differentiate both with respect to x. We have to use UV method, because z is function of xy. Dou z by dou x is function of xy. We have to use UV method, okay? Differentiate second equation partially with respect to x. We get, this is our second equation. When you differentiate with respect to x, take 1 by c square outside. Keep z. Differentiate dou z by dou x. When you differentiate dou z by dou x, it becomes dou square z by dou x square. Then keep dou z by dou x, differentiate this z, which becomes again dou z by dou x. UV method, right? UV method. Take minus 1 by a square outside. Differentiate x with respect to x, which is 1. So this is our new equation, okay? New equation, you can mark it as 4. Next we have to, listen here, I have got, if you want you can simplify this more. See, instead 4, 1 by, take c square that side. Z into, this is actually r. This is p square. Minus c square by a square, which is equation 4. Next we need, after getting r, we need t. What is t? Dou square y by dou y square. Dou square z by dou y square, right? That is differentiate this third equation. Differentiate this third equation with respect to y again. Okay? Differentiate third equation partially with respect to y. Take 1 by c square outside. Keep z. Differentiate dou z by dou y. Dou square z by dou y square. Keep dou z by dou y. Differentiate z. Dou z by dou y. Take minus 1 by b square outside. Differentiate y with respect to y, 1. Let us simplify. This is actually t. This is q into q square. Get c square this side, which is our new equation 5. Next we have to, after getting r, t, okay. Next we have to get s. In order to get s, you know, you can differentiate this with respect to y or this with respect to x, okay. So your choice, both will give same answer. I want dou square z by dou x dou y or dou square z by dou y dou x. So I differentiate this with respect to y now. You know z is function of xy. This partial derivative is also function of xy. So it can be differentiated with respect to y. So let us use, and listen here, I have to differentiate it with respect to y. Differentiate second equation. Differentiate second equation partially with respect to y. We get, take 1 by c square outside. Z is function of xy. This is also function of xy. So when you differentiate with respect to y, you have to use UV method. Keep z differentiated with respect to y. Take 1 by c square outside. Keep z, differentiate this with respect to y. Okay. Keep dou z by dou x. Differentiate this z with respect to y, which we get dou z by dou y equal to, when you differentiate it with respect to y, it will become 0. 0. See, this is, this is z into s plus p into q. When c square comes this side, 0. Which is our new equation 6. So we have got 6 equations. 6 equations. This is our given equation 1. This is first partially differentiated with respect to x equation 2. This is third equation. This is fourth equation. Right? Fourth equation. Fourth equation we have arbitrary constant. Fifth equation we have arbitrary constant. But you look at sixth equation, it is free from arbitrary constant. Okay. So when you do, automatically you will get answer. When you do automatically, or sometimes you have to do some adjustment to get answer. Okay. So this is the required partial differential equation, which is independent of arbitrary constant. Okay. So what is first heading? Formation of PDE, right? So solution will be given. We have to form equation. There are two types of solution. One is solution with arbitrary constant. Other one is solution with arbitrary function. Now we are finding equation with the help of the solution with arbitrary constant. So in all the problems we discussed, solution is given with the solution in arbitrary constant is given. So we eliminate arbitrary constant and we find answer. Answer is equation, right? Equation, partial differential equation. So first you have to see whether number of arbitrary constants and number of independent variables are same. If they are same, it is enough to get 3 equations. In case if number of arbitrary constants and number of independent variables are different, when number of arbitrary constants is more than the independent variable, number of independent variables, then we have to get 6 equations. 6 equations. And automatically some equation will give you answer which is free from arbitrary constant, or you do some adjustment, you will get answer. Let us do next last problem in this heading, where like this automatically we will not get answer, but when you do some simple adjustment, you may get answer. Let us see in the next problem, okay? So you know this, answer is not unique. We can get other equivalent PDEs. Once we solve the problem, right, where we got 4 answers, R equal to 0, S equal to 0, a problem, right? 4 answers. So answer is not unique, okay? So depends on our way of thinking, we may get answer, okay? Let us see the last problem. Find the PD of all spheres whose radii are the same. So we know equation of spheres, general equation of sphere. X minus a whole square plus y minus b whole square plus z minus c whole square equal to r square, where a comma b comma c is the center and r is the radius. It is given radii are same. So whatever center may be, radius remains same. So center a, b, c are arbitrary constants, but radius is fixed constant because radii are same, right? It is given radii are same. So you can change A, B, C, but radius, if you fix 2, it will be 2 for all the spheres. So it is fixed constant, not arbitrary constant, but these 3 are arbitrary constants, okay? So 3 arbitrary constants and 2 independent variables. So the numbers are not equal, right? So we will have PDE of second order, where we have to find R, S, T. You can find R only when you know P. You can find T only when you know Q, because it is again differentiated. It is again differentiated, right? So this is our first equation. So you should know it's not 4 arbitrary constants, okay? R is fixed constant. and these three are arbitrary constants. They can take any value, but R will take the same value. Okay. So here first let us differentiate first equation partially with respect to x. Differentiate first equation partially with respect to y. When you differentiate, it is 2 into x minus a, and this term becomes 0. 2 into z minus c dou z by dou x equal to 0. Similarly, 2 into y minus b plus 2 into z minus c dou z by dou y equal to 0. I hope you know, right? This is the last problem, the heading. So I need not explain more because you know the differentiation, right? So this is what we have now. 2, I can strike out if I want, I can strike out 2 into z minus c dou z by dou x equal to minus 2 into x minus a. 2 into y minus b equal to minus 2 into z minus c into dou z by dou y equal to minus 2 into y minus b. Strike out both sides 2. Z minus c into dou z by dou x equal to minus of x minus a. Z minus c into dou z by dou y equal to minus of y minus b. This is our second equation, third equation. I have to get 6 equations here, right? Differentiate the second equation again partially with respect to x. So it is UV method. Z is function of xy and this is also function of xy. So it is UV method. Keep z minus c, differentiate dou z by dou x, keep dou z by dou x, differentiate z minus c with respect to x. When you differentiate z minus c, dou z by dou x, c will become 0, right? Differentiate x with respect to x, which is 1, a will become 0, so minus 1. So this is my another equation. Similarly here, let us see. Differentiate third equation partially with respect to y. Keep z minus c, differentiate dou z by dou y. Keep dou z by dou y, differentiate z minus c, dou z by dou y. Differentiation of y is 1, b is 0. So we have here these two, right? And if you want, you can use notation now, no problem, because I am not going to differentiate it again. I use notation. This is r, this is p into p square, this is t, q into q square equal to minus 1. This is fourth equation, fifth equation. Okay. So listen here and let us do again s, right? I need s. You know how will we get s? Differentiate this with respect to y or differentiate this with respect to x. Both will give same answer and hence we get s. rt over pq over I have to get s. I differentiate second equation partially with respect to y. Both are functions of x and y. So UV method. Keep z minus c, differentiate dou z by dou x with respect to y. Keep dou z by dou x, differentiate z minus c with respect to y. Differentiate x minus a with respect to y, 0. So it is z minus c and this become s, this become pq equal to 0. I have sixth equation. Now I can use notation here, right? Because all 6 equations I have obtained. I use notation here. Z minus c into q equal to. Okay. So I have 6 equations. I have to think and do. The last few problems we have automatically got answer. We have not done anything. But here if I write, I have C arbitrary constant. Here C arbitrary constant. Here C arbitrary constant. Here A and C. Here B and C. Okay. So when you listen here, way of thinking. Your way of thinking will give you answer. Because you know, answer is not unique, right? Answer is not unique. You may get different answer. So this is solution for different equations. Okay. So listen here. If I choose this, I get z minus c value and I substitute it here, and hence I will get one answer. If I find z minus c from this fifth equation, and when I substitute it here, I will get one answer, right? If I get z minus c answer here, z minus c answer here, and when I equate the two, I will get third answer. See, I have told you 3 answers, right? 3 answers. See, get z minus c value, equate, you will get answer free from arbitrary constant. Or get z minus c, substitute it here, you will get another answer, second answer. Get z minus c, substitute it here, you will get another answer, right? Another answer. So, I have said 3 answers, right? If you try, you may get any other answer also. So, what I do now is, I get answer from 4 and 5. I find z minus c here. Z minus c into r is equal to minus 1 minus p square, right? Z minus c into r is equal to minus 1 minus p square. Z minus c equal to minus 1 minus p square by r, right? Similarly, from fourth equation, I get z minus c value. Z minus c into t equal to minus 1 minus q square. Z minus c into t is equal to minus 1 minus q square. This is from third equation, okay? This is from third equation. This is from fourth equation. Okay. Z minus c equal to minus 1 minus q square by 2. I equate the two answers. Both sides take negative sign common. It will get cancelled. Cross multiply, which is the required partial differential equation. Okay. So, whenever we have 3 arbitrary constants, sometimes when you find all 6 equations, any one equation will give you answer, which is free from arbitrary constant. Sometimes like this, if you think slightly, you may get answer, okay. This problem has more than 3 answers. So, if you find one answer, it is sufficient, okay. So, which completes this heading. So, we shall see next heading, formation of PDE by eliminating arbitrary function. Because we have another type of solution, right? That's why this heading is given. So, I recall you again the heading. What is the heading? It is formation of PDE. Usually in all the units, solve equation will be the question. But here form equation is the question. When you solve equation, you will get solution. You have to form the equation. So, solution will be given and you have to form the equation. So, there are 2 types of solutions available. One is solution with arbitrary constant. Other one is solution with arbitrary function. Okay. So, you can eliminate this and you can form PDE. You can eliminate the function and you can form PDE. Okay. So, first heading over, I have to do second heading. Let us see in the next video, okay. Thank you.